Hello everyone, this is Jake. In this video, I just wanted to talk through some of the planning and some of the designing of this entire activity since I figured some people might be interested in it if they're more interested in the engineering side of the cloud. So just speaking about generally the plan going into this lab, I wanted to make it a little bit different from the last digital forensics based Clue lab. And so I figured that incident response is a good transition since it's still an investigative side of cybersecurity. And it kind of just fit pretty well with exactly the format of Clue that we did before with figuring out the who, what, and where, since that's generally exactly how incident response works in the workplace. And so that was my focus going in, and I figured that why not adapt it to the cloud since this type of lab would be easiest to build out in a cloud environment. And so hence we came up with the idea for doing an incident response Clue workshop in Azure. The reason Azure is because Sentinel is probably the most built out and best SIM option out of the three major cloud platforms. And also, I'm just the most familiar with Azure, so it was kind of just the easiest in terms of setting things up. Now, the next piece of planning that had to go into it was what incident I was going to simulate in this lab. And originally, I had planned on doing some sort of web exploitation attack, but I found out pretty quickly that the setup for the logging inside of Azure was just going to be a bit too much, and so I went with a simpler option of just basing the attack off of one of the built-in analytics rules that come with Microsoft Sentinel. And if we go into Sentinel right now, I can kind of show you guys where that rule came from. So you can go into Content Hub right here, which is where you can kind of install add-ons to your Sentinel environment, and it comes with a bunch of different types of content. And so I can just go in here and search for Windows Security Events, and right down here you can see that this is the content package that I installed. And so it comes with 20 analytics rules, and basically I just went through some of those analytics rules. I can go into it right here in analytics. These are all of the rule templates that are kind of built into Sentinel now. And so the one that proved to be kind of the easiest to implement was this one right here, which is the process executed from a binary hidden in a base64 encoded file. This is a pretty straightforward rule. You can kind of see the query for this rule right here. It's just looking for a specific event ID, which is a process started ID, and then it's extracting some of the information from that event, and is looking to see if the command line contains one of these lines right here. I actually had to go in and edit this query because this top line right here is for Python, but that is not the correct decode function for decoding from base64, so I actually had to edit it. If we go back to my active rules, you can actually see that it's a little bit different right here. But aside from that, it was pretty straightforward to implement, and it worked well. And it really just allowed me to enter the command that you can find in the incident right here. So right here, here's the command that was kind of injected into David's workstation. And so pretty much what this is doing is it's just activating Python to decode this base64 encoded string of text. And then right after the end here, you can see that it's run as a subprocess using PowerShell, and then PowerShell to execute this actual command. As you could see, earlier in the previous video, when decoded, it shows up to be a PowerShell script, which actually I'll pull up again for you now. So back here in CyberChef, taking a look at this code again, you can see, like mentioned, it downloads this GitHub repository for the keylogger, and it outputs it to a zip file. Then it expands that archive, so it basically just unzips that file into the totally malware directory, and then it invokes an expression to actually run the PowerShell script in that file. And then down here, you can actually see that in case Python wasn't installed on the victim machine, it actually calls out to python.org to download Python and install Python, since Python is required for this keylogger to run. In addition, it also installs all of the requirements needed for the keylogger. So that is kind of the malicious command that I came up with. Since it includes the base64 and the decode function in here, it will set off this alert, and yeah, that's basically how the incident was created. Now, going back a little bit to how the environment itself was created, the first thing I did was to create subnets for each of the buildings on campus. And so we can go into virtual networks here, and very simple to create a virtual network. And then I just created subnets for each of the buildings and assigned them each a different IP address to signify that. And then I just randomly put workstations into each of these workstations, into each of these subnets. For the virtual machines themselves, right here in the virtual machines area, they're all the same, all very basic. I decided to make David's and Feiruz's a little bit beefier than most of the other ones, just because they were the two that had to do the most work on. All of the other ones have very, very small sizes just to keep the cost low. And then for each of these individually, I would remote desktop into them, and I would run through a few instructions just to get the logging set up. There was a few settings I had to tweak in Group Policy Editor in order to collect the necessary information. So now that the virtual machines and the virtual network was set up, I had to make sure that the correct logs were being collected. But before that, I had to set up a log analytics workspace, which is required to activate Sentinel. So right here, you can see ACM Cloud Law standing for Log Analytics Workspaces. And so this is basically just where all of the logs are being collected. By default, all of those virtual machines have a log collector sort of application installed on them. It's called Azure Monitor Agent. And so that's just actively collecting all of the logs that it's configured to collect and bringing them right here into the Log Analytics workspace. And as I mentioned, Sentinel is built off of the Log Analytics workspace. Go to Microsoft Sentinel, and ACM Cloud Law, you can see here, has the same name. It's just because it's built off of the Log Analytics workspace, and it's able to perform additional tasks on top of those logs that are collected, such as run analytics rules on all the logs and set off any incidents that may occur. Now, the logs themselves that I needed to collect was basically just the security event logs. Very simple. And so in order to do that, I would go to Data Connectors, and after installing that package from Content Hub, a couple of connectors would show up here, and both of them, I connected both of them, but you really only need the AMA one right here. And so if you click into this open connector page, and then you can add a data collection rule. Right here I have the security events rule, And so that's basically just collecting all of the security events from all of the Windows workstations. It was important for me to get logs from all the different workstations just to kind of show that, you know, all of them are connected. We have a little bit of visibility into each and every one, but obviously the only important ones were the David workstation and maybe the Feruz workstation ones as well. Another important aspect for me in building out this lab was to make sure that the attack was actually executed and that there was some sort of proof that it was executed, just because I thought it would be a little bit more realistic of like a keylogger is actually running on this machine. And so my solution to that was finding a keylogger that was basic enough to send traffic over a very simple protocol. And so I was able to come across this keylogger from David Bombal, and so very, very simple one where it's just sending it over HTTP, and it would be very, very easy for me to capture using a packet capture, which conveniently is built into Network Watcher. So I can go right here, go to packet capture, and then I can add a packet capture and select a target instance. In this case, it was David. And you can do any filtering or anything, but I didn't bother with any of that. Very simple, just start packet capture, and it captures any of the network traffic coming from the David workstation. Here you can see the resource group that I used just to organize and keep all of the resources for this lab in one place. And so, I mean, aside from the log analytics workspace, Sentinel, the virtual network, and all of the separate virtual machines and everything that comes along with them, it was a pretty simple environment setup. And so, yeah, overall, I really enjoyed putting this lab together. I'm really happy to say that everything that I put together in this lab is perfectly realistic. It's stuff that I've done in my own work experience, and I've seen other people doing their own work experience, and it's real experience that you can get from a pretty gamified little lab activity here. And so, once again, I hope you enjoyed it. And yeah, I hope you get inspired to do some testing in the cloud on your own, experiment with Azure on your own. And yeah, so thank you so much for watching.